Welcome, computer scientists and software engineers, to day 6 of CSC 222, Software Engineering. Thanks so much for joining us again. I appreciate your rapt attention. I had a couple questions. Before I show this one, I should say something. As computer scientists, you're familiar that when you're programming, there are several types of errors that could come up. The first type is a syntax error. Syntax refers to structure, so it's an error in the structure of your code. For example, you misspell a keyword, you forget a semicolon, other types of things. Syntax errors are caught by the compiler. So when you go to build solution, that will be trapped. And in Visual Studio, you notice that, like in most other Microsoft products, if there's something wrong, there's that red squiggly underline. So I usually turn that off because it bothers me as I'm typing or speaking things in that it's up there. But yeah, you can control that. A syntax error then is an error in structure. You'll be alerted to that. You won't be able to do anything at all. You won't be able to build or execute your particular code without correcting the syntax errors. One of the more difficult aspects, though, is sometimes we're not exactly sure why there's a syntax error. And one approach is the shotgun approach. Just start throw a semicolon, throw this, throw that. Oh, now it compiles. Life is good. Well, that's not always the best approach. Even if your code compiles, you know that there can be another type of error that's usually harder to uncover, and that's a semantic error. The word semantics refers to meaning of the code. So you wondering, why isn't my running total adding up? Or, hey, how come when I click this button that says reset, why didn't my running total go back to 0? Those are semantic issues that require a lot of investigation by us as programmers. And I'm sorry to say, but usually the way to determine those is to play computer. Just strip off any knowledge that you have of your code and just look at the statements one after the other and ensure that they're the right thing. Some of the most insidious types of errors are the environment errors. Syntax and semantics, programmers were trained to look for those things and uncover those things. Environment errors are, whoa, there's nothing wrong with the code, but something else is amiss. So if you get a strange build error, you get a strange deployment error, a strange run error, sometimes those can be corrected by going to the build menu. Now, I think I've told you to do build solution. These next three, rebuild solution and clean solution. Those are some other levels of trying to get rid of funny hooks and connections that might be left over from things that happen. Another horrible thing that happens, and I've had to work with at least one with this, is when you're working in the Visual Studio environment and you do debug, start without debugging, and you notice right away, up pops your code window and you say, no, it's not working. So you immediately switch back to your design view, you switch back into Visual Studio and you start making a change to the code. Don't do that. With that app still running, there are a number of parameters and hooks that are still open, such that changing your code may not actually stick. That's a terrible one. You change your code, but it doesn't really change the code. And you really start beating your head saying, what's going on here? All right. So just take things methodically, one at a time. If there's something wrong, be sure to close down any launched code window, start without debugging windows. And then the rebuild solution, clean solution, those can be some tools to help you get back to a known state. And then beyond that, call me up and I'll be sad with you. Assignment 7 that I gave you a little early last time. A few of you are ready to sort of move ahead, but I wanted to stick and make sure that the vast majority of us saw what was going on in assignment 4, understood the running total thing. So technically, truly, I'll give it to you today, but it's due on Friday. I'm going to try this. Rather than waiting a whole week, I think sometimes then that's just too long to stay away from it. So maybe if you look online at Blackboard, and this is my fault, but I think I told you before that when I tried in Blackboard to automatically update the dates, half of them went back 2 years to 2020. The other half went forward 2 years to 2024. And so I'm just having to manually go in and change everything. Ugh, I'm not very good at that. Assignment 7 should be due Friday. The other thing I want to draw to your attention is because a week ago was Labor Day, we're sort of offset a little bit. And before we had the CNCS assignment, it was, the second time we met on a Wednesday, due the following Wednesday. Well, the CNCS assignment, I pushed ahead a little bit to this Wednesday, and we'll see the next, just says CNC. From this point on until things get offset again by some other break in the future, perhaps, rather than quizzes and the CNCS assignment on Monday, those things will happen on Wednesday. So, and they'll cover the previous 2 days. So if I say a week, it's just sort of a logical week. Sure, mister. Look on Blackboard, the dates will be there. If they look like they're 2 years old or 2 years in the future, then let me know and we'll get them corrected. Let's review some things. We will spend some time taking a look at some apps, maybe some code. And if you have questions, we'll certainly cover those also. I know that you're going to be tired of hearing this, but it is important. At some point in time, in about 2 weeks or thereabouts, let's see. Yeah, in about 2 weeks or thereabouts, we're going to have an exam in CSC 222. I'm going to absolutely guarantee you that one of the questions on the exam will be define software engineering. You're going to start with this statement. Don't end here. Okay. This is a statement I've been telling you every day. You ought to start with this, but now you need to fill in the rest of the details. Software engineering can be defined as the management of the entire software development process. What's management mean? What's development mean? What's a process? Those are some questions that you can answer in order to flesh this out just a little bit. Management could refer to a classic situation of employee and supervisor, but usually refers to management of self as a professional, management of my tools like my environment and operating system, and management of the process in order, how am I going to actually create this product, the software development lifecycle. What's taking you so long to fix the control management system? Your leadership has taught me to give you laughably unrealistic timelines, then blame others when I miss deadlines. You're not even doing that right. I guess I need more of your leadership. We mentioned a few weeks ago the unholy trinity that affects software engineering. Projects are late, they're behind schedule. And yeah, it is not that uncommon. When the boss says, when's this going to be done? You give unrealistic timeframes, or sometimes you're forced to. Now, in an academic environment, you don't even have any say. You're an instructor like me. I say, hey, this is due then. Do you suppose those are laughably unrealistic? No, they're okay. You can do it. You're computer science majors. You can do it. Another way we've thought about software engineering is give a description. We have defined software engineering as professional problem solving. Early on, I shared with you some aspects of professionalism, and I'm going to continue to do that. One of the reasons for the C and CS assignments is so you can think about the concept of professionalism. Another major reason is so I could be true to the mission of Concordia University, Irvine. Professional problem solving. So this week, actually, we started this last time, and we'll say a little bit more this time, and then by Wednesday, you will complete C and CS2. My second aspect of professionalism, being civil. Civil. Before we investigate what being civil means, and I imagine you do know, I want you to think about this. The software development lifecycle is a framework for our job. It's the process that we follow. It's the steps we've been talking about so far, requirements, and this week, specifications. The 10 Commandments then serve a Christian as a framework for our lives when it comes to ethical and moral responsibility. Certainly not when it comes to salvation, but when it comes to ethical and moral responsibility, the 10 Commandments are a guideline or a framework. The second commandment, you shall not misuse the name of the Lord your God. You know, I'm an old guy, right? You can see that. I was having this discussion with somebody who was not quite as old as me, but still, they were just mentioning how taking God's name in vain has become such a standard part of culture. Everybody throws out OMG without even knowing maybe what it stands for. And people, even Christians, I hear all the time just saying God as a pejorative or just as an exclamation. What does the second commandment mean? You shall not misuse the name of the Lord your God. Martin Luther wrote a book called a catechism. If you grew up Lutheran, you probably were exposed to the catechism. The catechism is a way to give instruction in basic Christian doctrine through questions and answers. And this was Martin Luther's famous question. What does this mean? Second commandment, we should fear and love God so we do not curse, swear, use satanic arts, lie, or deceive by his name. I want you to notice, however, that for almost all the explanations of the commandments, there's the negative aspect first, Luther lists, but then Luther also, in the context of God's word, shows the positive aspect. You shouldn't curse or swear, but at the same time, we use God's name, we call upon it in every trouble, pray, praise, and give thanks. So there's both a negative side and a positive side to it. And when you're thinking about how do I relate the aspects of professionalism, like being civil, to the commandment, sometimes it's helpful to think about it in a positive sense. This was an ad campaign that was on a number of years ago, about 5 or 6 years ago here in the Midwest. I don't know if you ever had it out west there, a whole bunch of billboards. And one of them said, if you must curse, use your own name. Signed, God. Yeah. You wouldn't know who Monica Harrell was, Monica Harrell loved to let loose with a bawdy curse. But then she discovered science that suggests swearing is more than just a bad habit. It might actually affect your mental health and how well or poorly others treat you. Yeah, still today, I think that's true. If you haven't heard this very old joke before, well, here you go. Boss, you always have to have funny creatures in comics, right? Helen, looking for a new ombudsman. Your experience in the afterlife makes you an ideal candidate. I'll take the job, but call me Mrs. Fry. I have an issue with management. Go to hell and fry. Yeah, not God's name, but kind of borderline, huh? Thanks for not laughing. Downton Abbey still on? Now that we've lost Queen Elizabeth, maybe they are no longer on. I love the quote, vulgarity is no substitute for wit. Now you know. In 2 weeks, on day 10 of CSC 222, this is day 7. So a week from Wednesday, I guess that's not quite 2 full weeks, is exam number 1. Say more about it as we get closer. The exam will happen online at Blackboard, similar to the quizzes you've taken. They'll just be a little bigger. The exams will be, they'll contain true, false, multiple choice, and a few short answer questions. Yeah, Ben.
I was just wondering if there was going to be a study guide, or is it just cumulative of all the material we've covered thus far?
Great question. I will post a list of potential topics and questions that you should know. And that should pop up on Blackboard by Wednesday. Good question. The way to ensure that you're ready for this is to, well, you're reading the chapters because the quizzes are based on those. But you notice that I am talking about a number of things that are in the chapters. Anything that's both highlighted in a chapter, like mentioned more than once, and we discuss in class and I mention, that seems like a big topic. I'll give you an example. There will be, I don't know, maybe 3 short answer questions. Oh, for me, short answer is really short answers, not essay. Don't have to have a topic sentence. Don't repeat the question in the answer. Just answer it and move on. But I'm just going to flat out tell you, one of the short answer questions you'll see on the exam is define software engineering. So you will dutifully write the management of the entire software development process. Don't end there. Flesh that out a little bit. This is not a chapter. This is not pages and pages, but I imagine you have to write 4 or 5 sentences to fully explain software engineering. So yeah, there'll be something there, but I think you've been cognizant enough seeing what's important in the text and what's important in discussion that you'll know. The exam is open book, open notes. Warning. That could lead to spending a lot of time looking things up, and you won't have the time because the exam is also timed. If you are totally stuck and can't remember one thing, then yeah, it's okay. You can go to the text, you can go to your notes, and I would encourage you to have some well thought out notes arranged in a way that makes sense to you. But the exam is timed, so you won't be able to check everything as we go along. Any other questions right now about exam number 1? I'll make sure that I don't really want to call it a study guide because some of you may not think there's enough in there, but the list of topics and interesting questions that will be posted by Wednesday. I want to review a couple things on assignment 4, what I'm calling sprint 1. We've got to say some more things about this idea of a sprint, but I'm going to hold off a little bit. I also call this a POC, a proof of concept. For right now, just hear the terms, nod our heads, we'll flesh them out later. I mentioned the last week that when it comes to the user experience is the feeling the user has when they're working with your app. Much of the feeling comes from the user interface. And here in the United States, in most Western cultures, we think of things vertically, top to bottom. Phones have kind of enforced that, although books were that way too. Or horizontally, if they're horizontally, it's left to right. Now, users, as we mentioned before, think this way, IPO. They don't know what the letters stand for, and they probably don't catch on even if I told them, but they think input, process, output. So here's the input. And again, single box. Don't have more than one and only allow one value at a time. If this idea is still strange to you, please send me a message and we can chat about it, Zoom about it, or I can send you some more documentation. We all got to be on the same page with this event-driven model, the running total design pattern. One input box, and then notice this add button separates the input from the output. Single output value, running total. Now, I had a couple other ones here. We didn't do undo last. That will be for the next one. We'll talk about it. But the clear button, and you gave it a good name. And this is a menu item, which you didn't need, but you'll need it on the next one. Here's one way to do it. It didn't have to look like this. However, if you had more than a single input or you demanded multiple items here, I said, no, that's not what we're looking for in this specific case. If you had your add button below, I asked you to move it in between. This is part of user experience. At least at Concordia University, Wisconsin, we introduce user experience constructs in software engineering, and then we have a course in it that comes afterwards. I should check and see if you guys at Irvine do it too. But user experience, really important. I showed you the code before. Let me just point out, you need an initial comment. Every module, now module is just a generic name. We're using C#, so they're methods. Every module needs an initial comment that says at least three things. The purpose, what is this thing? The author, and the date. Those are important. So get in the habit of doing that. I haven't deducted for that yet, but I may in the future. So have a comment up front. And whether you have it up here before the class, you want to have it within the class, right now that makes zero difference. Somewhere such that another person or you 5 months later can come here and say, oh yeah, that's what this is about, right? Now, I don't have any inline comments. I always think it's a good idea to have some, but remember the purpose of a comment. A good comment explains why. If you're saying set the variable running total to 0, that's dumb. I could see that. If your comment is set the running total to 0, I could sort of see that too, because see, I called my variable running total. Yeah. I would say that every private method, like this button one click, should have an initial comment also. Could be straightforward. It could just say compute running total. It'd be easier to find that. Now, if rather than button one, I called my button compute running total or something like that, I might not even need a comment, but it's a happy habit. Do it. You need to be doing try and catch. Try and catch. In other words, if something is input other than can be resolved to a double, if I can't cast that input as a double, if it's a letter, then rather than dropping dead, this exception will handle it. All right. So with that said, hopefully we're all on the same page now. because assignment 7, what needs to come is going to build on this, and the next assignment will build on that, etc. So if you're not quite convinced, either review the material we've said. I think last time's course cast near the end, we spent some time, and it's certainly online also in some documentation. Or please send me a message. Let's work through it. Zeb goes to the doctor. Doctor, you've got to help me. I believe I'm a deck of cards. Take a seat. I'll deal with you later. You guys are just not playing along, are you? All right, well, that's okay. I'll take care of you. Our software development lifecycle has 6 identifiable phases. We've talked about requirements. I'll review that just slightly now, and then we'll move on to specifications. The first 2 aspects of the software development lifecycle, sometimes you'll hear people call it the front end of the SDLC. Now, warning, front end has a different terminology in other aspects of computer science. For example, in web development or in client server applications, we split 2 types of processing, the front from the back, the client from the server. So front-end developer to some people might be the person who's creating, the local JavaScript code for the website. For us, software engineers, in the context of the SDLC, front-end development is doing requirements and specifications, what before I called the idea work, the hard mental machinations. Let's briefly review requirements, because it was last week and that week got broken up anyway. Fundamentally, requirements are going to focus on why is there a problem, and specifically, what is the problem? Requirements focuses on why is there a problem, and that's a key question. Why? What is the problem? And another thing requirements focus on is what's needed to solve this problem, and why is that? The example I gave is, do I need an app? And why do I need an app? Think about our add numbers problem. Why don't we just hand that user a calculator? Here, that'll solve the problem. No, it won't, because of the constraints of the environment where the user is working. The user has their hand on the computer keyboard. I can easily control tab to a different app, use the 10 key to do this. I can't pick up a calculator and do things. So that's all explained in the requirements. From a computer science perspective, we focus on the outputs. We focus on the information that needs to be generated. So here succinctly, if anybody ever asked you, well, what's the requirements phase of software engineering all about? Oh, there's one more thing though. This is what it's all about. A prototype. One way to communicate with our users is to develop a prototype. I can create that form very easily in Visual Studio. Harder part often is putting the code behind that such that it actually does what I want. But I could see this, and Visual Studio is a rapid prototyping tool. I can show this to the user and say, what do you think about this? And the user may ask a question, well, what's that mean? You explain, oh, okay, got it. Well, yeah. They say, yeah, I could do that. Or the user can say, no, that is nothing like what I was expecting at all. Let's do it this way. It's easier for the user to think visually and graphically when it comes. Why? Because they're focusing on the information. That's what they need to solve the problem. Here's requirements in a nutshell. Good. I think I'll just let you read about this in the text rather than spending the time going through this. But Requirements are done in other places rather, in addition to software engineering. If you wanted a new building, the first thing you don't do is you specify the type of building material. Hey, it needs to be wire-based stucco, or it needs to be whatever. No, the first thing you do is explain why. A good architect would come to you and say, why? What's the purpose of this building? Once they understand that, then together you can work on the specifications. In case you're wondering, I know you've had to do running totals. Chuck Norris doesn't do running totals. Chuck Norris walks and roundhouse kicks. Good way to solve problems, just not the way we're going to do it. Be sure to read the text about these ideas of analysis. During the front end of software engineering, we're trying to understand the user's problem. Those are analytical techniques. We're trying to analyze what's happening there. And be sure you take a look at diagramming tools. We'll just do this later on. But not only are prototypes a good communication tool between us as the developer and our client, diagrams are a great way for us to understand the problem, and also a good way to make sure the user and we are on the same page. So would you take a look at that in the readings? Especially note this one type of diagram, use case diagram. So let's move on and talk about specifications. Let's just preview it concisely, and we'll hit some more of it next time, and you'll read about it too. Here is the fundamental question for the specifications phase of software engineering. What does a good solution look like? What does a good solution do? The key word in specifications is what. What does it look like? What does it do? Another way of expressing that in more computer science terms is, what are the features and functions? What are the features and functions that need to be provided to solve the problem? There's a slight difference between feature and function. Feature is an out-facing thing on the user interface, clear. The function is the internal algorithm that implements that. For us and for now, we'll just call them the same thing. You can use one term or the other. What are the features? What features does the app need? What functions does the app need to perform? What's a good solution look like and do? What are the features and functions? And now in the specifications phase, we're going to focus on the total UI, inputs and outputs. We did outputs before. Now we're going to focus on the inputs. Bear in mind that input for a computer scientist isn't just data. It's also commands. So it's not just that text box that says the current weight of the shim. It's also any of the buttons like add and clear. Add and clear are technically inputs. They are events to the program, but they are input because they're driven by the user, not by the code. Specifications will answer all the what questions. Now you're saying, do the specifications tell me how to solve the problem? Nope. That's the next phase. Sorry. My speech rec app Every once in a while, I've told it, go to sleep, stay asleep. Every once in a while, it wants to wake up again. Answer the what questions. And another important aspect of specifications is another prototype. The first prototypes, the ones we develop in requirements, are really not meant to represent the final product. They're more discussion along the way. Now that we've got much more detailed information, we can create better prototypes. Prototyping is an iterative process, back and forth, add, subtract, etc. There's another important aspect of specifications, and that's planning. We're going to talk about this. We're going to hold off to the end of this unit, the beginning of the next unit, because for us, the planning in software engineering would be, how many software engineers does it take? Personnel. How much money will it cost? How much time? Guess what? You don't get to decide any of that. How many people? One, you. How much time? When I say it's due. How much does it cost? Nothing. These cost me nothing. But in actual software engineering, those would be important considerations, right? And they happen here as an aspect of the specifications phase. Yeah, that's funny. That's funny. All right. Time for a break. I think I mentioned this last time because I asked you all for your favorite soft drink, and I already got onto the thing about what people might call it. Generic names for soft drinks by county. Really? Okay. Most popular term used: pop, Coke, soda. This says Southern Californians would predominantly say soda for it. This says that soda is fairly popular here where I live, right about there. The trouble is, I called it Coke. See, I grew up, where's Sacramento County? Right there? Yeah, I don't know what that's supposed to be telling me, but regardless. Rather than unmuting and talking today, would you do me a favor? Would you jump into chat and would you just tell me what term, your term for soft drink, pop, soda, Coke, or something different? You don't have to tell me your name, it will show up. Just put it in chat. I'm just interested. If you're going to refer to a soft drink, you would say pop, soda, Coke, or something different. Yeah. Wow. Wow. Okay. Soda dominates. Few Coke. Yeah. Nobody. Exactly. Water. Nobody says pop. That's weird. Actually, apparently, it's supposed to be soda pop, but I don't know. All right. Thank you, folks. I appreciate that. Always good to have something different to do. In the text, you'll be reading about different software development lifecycle models. One we're following is one, and there are many other ones. I said this a long time ago, and hopefully I wrote it in the text too. The odds in the future, you graduate Concordia University, Irvine, you're snapped up by whoever the hot local employer is. The odds of them using our software development lifecycle are really small, but they'll have aspects of ours, and the general ideas transfer to anything. So just realize there are different approaches to software development. This approach, the one that I'm sharing with you, isn't the correct one. It is just one. Remember, the goal of software engineering was to professionalize software development, move it from all art to give it a wrapper, a framework. In other words, to manage it. Well, there are different management approaches, there are different managers. Different approaches to software development are possible. Later on, we're going to morph ours into what I call a modified Scrum. Because right now, the vast majority of software engineering companies use Scrum. Well, they don't really, but they say they do. So we want to know that term and what it means. Historically, one of the earliest software development lifecycle models was build and fix. You can imagine that you're thinking, it doesn't sound really good. And you're right. This was a zero discipline approach. No discipline to how I'm doing. I just build something. If it's wrong, then you fix it. Usually considered bad, right? No one would admit to doing build and fix. Could be some that do this, but it basically means there's no framework, there's no structure, there's no guidelines. There really is not much of a model at all. And this is why historically there was the software crisis. Over budget, behind schedule, full of bugs. A long time ago, I mentioned these various levels of CMM, capability maturity model. The Software Engineering Institute at Carnegie Mellon University came up with 5 levels as a way to assess the process that software companies do. They didn't care what you called it or the steps or anything else. They just said, hey, let's take a look. Let's compare it to these guidelines. CMM level 1 is the worst. CMM level 1 says this: you have no idea how the process of software goes. If you were asked to recreate this exact same product immediately after you built it the first time, you couldn't do it. You couldn't recreate it because you have no structure, no framework, no documentation. You have no idea what you're doing. CMM level 1, bad. Because of that, this was the pendulum swing to folks saying, look, people are doing their own thing. It's too artistic. We need to put a very rigid structure on it. And the idea that was developed was the waterfall model. This is a sequential model. The idea, it should probably be called water wheel, like this thing here. Because, the water pours into one bucket, which fills and then goes down, and then the next bucket fills and goes down, and then so it goes. Is a couple things to say. First of all, it flows one way. You wait for one bucket to fill before progressing to the next. So in waterfall, you would do all the requirements, and then they'd go by, and then you do all the specifications, and it'd go by. And then you do all the design and it'd go by. It sounds great, but there's no feedback until the very end. Are we doing the right thing? Can't always tell. So if you mention waterfall to any practicing software developer, they will scream in horror. They evil, get that out of here. It's people will not give it any credence. There were some good aspects, but nobody would do waterfall anymore. So what are the options? Well, an option is the incremental model. There are lots of variations of the incremental model. The incremental model is iterative. You don't do one, see, that was waterfall. Do all this, do all that, do all this. But the incremental model is iterative. The product is built in stages. I don't build the whole thing all at once at the very beginning. I build bits and pieces of it. Scrum is an incremental model with some aspects of iterative also that we'll see next. I'm sorry. The product is built in stages. We're not doing all of the add numbers program up front. We're doing bits and pieces of it. Incremental model. Product is built in stages. Now, related to that is a spiral model. Hey, didn't I say that? Did I just say that before? No, I said iterative. Here I said iterative. Yeah. Well, so what's different? What are we iterating? Before, we were iterating on the product. Now it's the process that's iterative. Do a little requirements, little specs, little design, little implementation. Do a little bit more requirements, a little bit more specs, a little bit more design, oops, etc. So it's the process that's iterative, not especially the product. Today, DevOps, Scrum, lots of other modern software development life cycles use both of these in specific ways. I hear you have an MBA, just like the jerks who ruin the economy. I'm going to punch you so hard that it hurts everyone who has the same degree. Folks, I'm sorry. This has nothing to do with software engineering or our current topic, but it just, as I was looking for meaningful comic strips, Alice here is hilarious. She has the so-called fist of death. And what was that hideous story? I need a way to get through this too. You okay with that? Thank you. All right. At one time, there was a specific model called the rapid prototype model. Guess what happens in the rapid prototype model? You build a quick prototype first. What's a prototype again? The user interface in software. When first unveiled, this is kind of like a revolutionary idea. People said, whoa, it'd be very helpful. It's no longer a standalone idea. It's part of every modern software development life cycle. Everybody creates prototypes quickly up front and also iteratively. Let me give you maybe a better analogy for a prototype. What in the world is a prototype going to be applied lots of different ways? Luke 11. One day, Jesus was praying in a certain place. When he finished, one of his disciples said to him, Lord, teach us to pray, just as John the Baptist taught his disciples. Jesus said to them, when you pray, say, and that's the Lord's Prayer. Now, interestingly, the Lord's Prayer was designed to be a prototype. Teach us how to pray, the disciples said. Yet, this prototype also serves as a standard prayer. If you're a Christian, the odds that you said the Lord's Prayer yesterday, if you went to church, are pretty high. Or if you said the Lord's Prayer in chapel, I don't know what time you guys have chapel. We have chapel 9:30 in the morning at Concordia, Wisconsin. Do you have, I should know these things. Somebody put in chat if you know. Do you have chapel every day? And when is your chapel? If nobody knows, I'm going to feel sad. Do you have chapel every day? Okay, good. Every weekday except Wednesday and 10:30 to 11. Huh, interesting. Okay, good. Thank you. Now, will I remember that? Probably not. So you might have to remind me of that sometime. Oops. Back to our story. And if you are Lutheran, you remember going through the catechism and seeing the 7 petitions in the Lord's Prayer. So it's really designed to be a model. Hallow God's name, ask for spiritual, ask for earthly, repentance, etc. Do you have to say those exact words? No, Jesus was getting across these basic ideas. But it also does serve as a valid prayer for us too. Prototypes then are that. They could be the actual thing, or they could just be representative in a bigger sense. Sorry, this is really long, but it's too good not to pass up. Alice, if there are no objections, I'd like to start the meeting with a prayer. ASOC is not a Christian. Yea, though I walk through the valley of idiots, I shall fear no downsizing, for I have a fist of death and highly marketable job skills. My investment portfolio isn't doing as well as I'd hope. So if it's not too much to ask, I need a higher return so I can escape these clowns and live in splendor while they stew in their own bile. Boss, maybe we won't do this again. Whatever you say, heathen. Yeah, Alice kind of missed the prototype there. Error. Hi, 404. Okay, you know what? You just do the search. Okay, I must have had something extraneous in there. Best software development models for a successful product. Oh, I grabbed the 21 version, so it probably got deprecated somewhere. Software development lifecycle models show how to navigate the complex and demanding process of building software. A project's quality, timeframes, budget, and ability to meet the stakeholders' expectations largely depend on the chosen model. So choosing the right SDLC model makes all the difference. However, there are more than 50 recognized SDLC models in use nowadays. Each brings its favorable aspects and disadvantages for a specific software development project or team. What I was going to point out as we got into this story was they list, I forget, 8. Does it say it's supposed to be 08 best software? Is that 8 in a series? I don't know. They're going to say, hey, if you're developing this kind of project, here's a good, if you're developing this kind, nobody's going to do that. No organization is going to say, okay, let's become expert in 3 different software development life cycles and choose the right one depending upon, the circumstances. Sorry, nobody's going to do that. Be a great idea. It just doesn't happen. And that's why later on we'll point out that Scrum, which is the one that most people glommed onto, has a couple of thorny issues involved with it. Okay, you find the 22 version of this, please. Thank you. All right. I wonder why that is. And I wonder what I'm sharing. Okay. What's the difference between an approach and a software development lifecycle? Sometimes nothing, and sometimes approaches are an aspect that can be used within a software development lifecycle. This concept, paired programming, is a very interesting idea. You could probably guess it means you have 2 people working together to program. Organizations will take this to the extreme whereby they'll have 2 people programming, but only a single computer. You'll take turns. One person will enter the code, the other person will look at the code, and then you'll discuss it as you go along. Really interesting. Later, we'll mention agile methods. I don't know why it's all capitalized. Scrum is not an acronym. It's just a thing. DevOps, and we'll see that later too. So if you've looked out there, you've probably heard of several of these, if not all of them. And this is not Windows XP, it's extreme programming. Agile methods, extreme programming, paired programming, Scrum, DevOps. Read a little bit about in the text, but for now, just be cognizant that there are a number of philosophies, concepts, and approaches to be carried out within the software development lifecycle. I think you know this, but let me make it explicit. The problem-solving process is heuristic. It's not algorithmic. The problem-solving process is heuristic. So what's a heuristic? A heuristic is a guideline. People will say it's a rule of thumb. It is a feeling. It is a trial and error method. It's really just a generalized thought process or guideline. Now, you know that's an algorithm. There's nothing fluffy like that at all. An algorithm is a detailed, unambiguous, and effective set of step-by-step procedures for solving a problem. Computers follow algorithms. They don't follow rules of thumb or guidelines. They don't do trial and error, etc. They follow algorithms. Problem solving, we can't list the 12 steps to solve any problem. There's just lots of guidelines. But there's no actual algorithm involved. That's similar to the software development lifecycle. The SDLC is going to tell you what to do, but not how to do it. Requirements. You need to figure out why there's a problem. And well, how do I figure that out? It doesn't tell you. It just says, here's what needs to happen. In the text, there's a little bit about analysis and communication, etc. But all those are really just heuristics. They're guidelines. There's no hard and fast rule on how to carry out the software development lifecycle. Back to civil speech. And I made a bet with Ted that you could ignite this match by swearing at it. How dare you bet against me, Ted? You dang. See how good civil speech is? Thank you for noticing that. Yeah, you know what? I just have this here because you'll see this referenced in the text, the grand ideas of computer science. It's something that would already been drilled into your head if you were a CS student at Mech 1. No reason for me to drill it into your head there. We believe that there are 9 what I call grand ideas of computer science, that if you understand those serve as the foundation and the jumping off point for everything we do in computer science. So can I just ignore those? Good. Let's talk about the next thing that you need to do. And I want to show you a potential app that would implement everything in Sprint 2. This is homework assignment 7. And yeah, I've mentioned this a couple of times. I don't want to renumber the assignments because then that just causes consternation in Blackboard. But I originally laid out a bunch of stuff. And we're just not going to do some of these things. Okay, sorry. So you're wondering, where's 5 and 6? Well, they're there. They're just hidden. In addition to a single output field that has the total weight, you're doing a running total on weight. Now you need to count how many shims have been added up. So here's another running total, but this running total isn't on the input value. It's on the number of times that the user typed in a value. Make sense? I enter the value for 5 shims. This is 5. The weight is, I don't know what, 2.76. Input field, still the same data input field, just the weight of the shim. But now commands. Before we did an add, and you did a clear/reset, Now you're going to add to it one more command. This is still an input. Undo the last item. You're familiar with that, right? What if I'm just buzzing away at 100 miles an hour and say, oh, darn, I didn't mean to type in 0.22. It's supposed to be 2.1. Well, how do I undo that? User does it simply with a command. How are you going to do it? You're going to have to implement that. And there are some other things. So we'll talk about these a little bit next time also. What do I mean by reset the input field? Now your error message needs to come up on the form itself. Don't throw up an outside box. Have a good error message on the form. I'll show you what I mean by the focus. I want you to add a menu. Doesn't have to do anything yet. Just need to figure out how to add a menu there. And you already did the form name. Just give it some thought. Or if you didn't do the form name before, think about it. All right. Let's see if Windows has dropped dead in all the time I've been sitting here doing nothing. I think I mentioned the last time we chatted that I contacted your IT support organization and asked, is there some way that students get a hold of a license for Windows? And they said yes. They then asked for your e-numbers, which I sent to them. And as far as I know, nothing has happened yet, unless you got emailed directly from them. I don't think anything's happened. I'm in the same boat as you. I can't get my IT support to properly give me a license key such that I can activate Windows. But if you're running on a Mac like I am, and you're using Parallels or VirtualBox or something similar to run a virtual machine in Windows, yeah, I mean, you can download and install Windows just without a key. It can't be activated. I'm not advocating doing this, but we'll get you that key ultimately. What? More updates? Go away. All right. Here is one way to think about assignment 7, sprint 2. First of all, you've got a good name for it. Call it whatever you like. Well, I shouldn't say that. Give it a good, meaningful name. The user will know. This is a menu. This isn't just a button like these. This is an actual menu. Now, right now, it doesn't do anything. I don't think. I didn't implement anything. All you have to do is figure out, how do I add a menu bar to my form? Just have a single item like help, and we're set. So that's something new. Way to shim, same as before. Add, same as before. Now notice two outputs: current running total weight and current count of shims. The other thing you could see right now, can you tell? If you look carefully, you can see the cursor flashing in my input box weight of shims. In other words, the focus is in the input box. For most people's apps before, I couldn't just type a value. I had to put my mouse pointer and click in that field. And once I clicked in that field, now the focus or the cursor was there, and I can type in a value. I want you to automatically put the focus there. How do you do that? It's a form property. I'll give you some hints next time, but I think it's very helpful for you to think about that. Here's what I'm saying. Right now, I can just type something in. For many of the other apps that you weren't supposed to do this in assignment 4 anyway, it's okay. But you know how it worked because you ran it too. I run it and then I have to click in there. No reason for that. Now, also in assignment 4, I asked you to connect the enter key to the add. Did I show you how to do that? I better show you next time if I did not. Okay. So that way, rather than having to use, I can use the mouse still, and I can click in here, but I don't have to. I can just press the return or the enter key. Now, note what happened. When I selected add, first of all, yep, 3.56 and 1. That's correct. But notice that way to shim's input value, the previous value was wiped out. And the focus was put there. Now it's ready for me to type in a new value. That's what I want you to do. Think about it. We'll say some more next time. Now, don't forget about error checking. You've got to do error checking. What if I meant to type in 2, but instead I typed in W? Now, rather than a pop-up window, I want you to have a good message, and that should appear here on the form itself. Notice that. You're saying, that box looks a little different. Yeah, it is a protected box. You can't type in things there. And I look at that and I say, oh. Now, should I have wiped out the W? Good user experience says, leave that there. If I wipe it out, the user's going to say, well, hey, I typed in a 2, what's wrong? Now the user can clearly see, oh, I meant to type a 2, but I hit the W key. Boom. So yes, now I have to get rid of this. And now I have to type in a value, etc. 2 other commands. Undo last. Well, I forgot to double check what the value there was before. Maybe we should, let's just type in 1. So we know our last value input was 1. Undo last will get rid of, notice, it subtracted 1 from the current running total weight, subtracting 1 from the count of shims. You do not have to allow multiple undos. 1 level of undo. Multiple undos would require a data struct, an array or something. A linked list probably would be good. But you just keep track of the last value. If the user does undo, you get rid of it and move on. Clear gets rid of everything. And then notice again, the focus is back up, ready to begin. So you don't have to copy my layout, but these are the kinds of things that the user is looking for in Sprint 2. And you'll find these requirements and specifications online as assignment 7. Any questions about this as a possible implementation of assignment 7? Okay. It's not the end of 2022, but it is actually the end of today. So for just a couple of you, be sure that you understand assignment 4. Do it, submit it. Let me look at it. Let's get caught up. The vast majority of you, you're A-okay. Thanks for your hard work. At this point in time, I might recommend that you start a new project. It'd be easy, I know, just to tack on to what you did before, but there's some benefit in starting a new project and thinking about things. You've done things one way and you thought, that's not the right way. And I see you saying something different. So this way we just start fresh with a brand new project. That would probably be good. Questions, comments, concerns? Darn. Folks, thanks so much. I know this is a difficult way to do it. I wish we could sit there, go in the lab. We can all look at the same thing and I can actually derive feedback from your faces, but I really do appreciate the effort. You had to put in more effort into this class because of its mode. And software engineering isn't easy either. This is all strange. So thanks for your hard work, but continue putting forth the effort. So I'm gonna stop the recording, but before I do that, I'll tell you, have a nice day, have a happy Tuesday. I'll see you all online